Oof.
Good morning, everyone. Thank you for joining us for this morning's webinar. In just a moment, Mike Holmberg, Ignition Associate Brand Manager, he's going to share his insight and knowledge regarding solutions to make baling easier. Just a quick housekeeping note, this is a live webinar. And for those of you on your computer, there is a chat button at the bottom of the screen that will allow you to type in your question. And all questions will be addressed at the end of the presentation. So now at this time, please welcome Mike Holmberg.
All right, good morning, everyone. Thanks for joining us today. Like Lori said, we are going to talk about Anchor for Hay, primarily focused on what it can add to value to your customers and how you can help to position this to them. So with that, a few questions you might ask to your customers. One might be, do you ever struggle to get hay put up? Maybe it's just a challenge every time to get it put up right. Another question is, does the window of time that you can bale high quality hay seem to be too short? So maybe you can't start baling until 2 o'clock and by 4 o'clock it's already too dry. And that 2-hour window isn't enough time to bale all the hay that they need to. Does humidity ever prevent them from baling on an ideal day? So I'm from Minnesota, and I think of a nice day where the sun's shining, the wind's blowing, it's 80 degrees, and the hay won't dry down. And what's the missing piece there? And that's humidity. And the last question is, does rain ever force you to bale hay before it's dry? So I think, some guys can plan the rain based on when they cut hay. They cut hay, and 3 days later it's going to rain, and they need 4 between cutting and baling. So just a few things that challenges that might come to mind. And it's all surrounding moisture. So looking at the impact of moisture, Arizona State did a study, and at 80% relative humidity, the driest hay can get is 23%. So the air is acting like a sponge and taking moisture out of the windrow. But if there's a lot of moisture in the air, it's actually working the other way, and it's putting moisture back into the windrow. And moisture has an impact on leaf loss as well. If you bale below 16% moisture, your leaf loss increases between 5 and 25%. Depending on equipment and other circumstances. But that's important because leaves contain 70% of the overall nutrients, including 75% of the protein and 90% of the vitamins. So leaves are really important to hay quality, especially when you look at out. And another thing I hear a lot is that, well, it's only the outside few inches of my bale, so it's not a big deal. The rest of the bale is fine. But the outside 3 inches of a round bale is actually 20% of the overall bale volume. So a few inches on the outside translates to a lot of loss when you look at the whole bale. And the cause of heating. So if you bale hay too moist or too high of a moisture, you do get heating. And at below 120 degrees, a lot of that is that the plant is still trying to grow. So it's consuming the soluble sugars and releasing heat and CO2. Not much impact in quality there. Between 120 and 140, this is where you get your caramelized tobacco hay that I'm sure we're all familiar with. You can actually have your protein bind to your fiber and become unavailable during that time. So you do lose some nutrient value as well. And most of that heating is caused by bacteria and fungus. And then when you get to 140 to 160, there's actually heat-resistant bacteria that rapidly raise the temperature, and they release enzymes to do that. So it might take 2 weeks to get up to 140 degrees and 2 days to go to 170. And you're like, how, why, what was the difference? What changed? And it was heat-resistant bacteria that were actually releasing enzymes that made that heat go up. If you see in the bottom right here, there's a little fire danger graph, and we'll look at that now. So at 160 degrees, you want to take the hay apart, maybe stack it outside, let some airflow happen. At 175, you should call the fire department before you do that. And then when you get up to 200 degrees, you should just shut the doors and walk away. Because you have enough heat and fuel for fire to happen, the only thing missing is oxygen. So when you get over 200 degrees, it's pretty likely that your hay is going to start on fire when you start taking the stack apart. So the answer to that, the way to bale higher moisture hay without that heating or fire concern, is Anchor for Hay. This is a dry granular product that lets you bale hay at a higher moisture with reduced heating, which is going to help prevent spoilage and save nutrients. There's a few components in here. There's an organic acid, which is lactic acid primarily. There's also an inoculant blend and our patented microbial catalyst. This is going to let producers start earlier in the day. Maybe the dew isn't totally gone yet. Bale longer at night, so when the dew sets on or maybe the humidity creeps up, the sun goes down, they can keep baling and keep baling in humid conditions. So I talked about that ideal day where you really want to go today, but you're just not able to. This is a product that lets you do that. It's going to let you save more leaves while reduce heating, and a big point is that it won't rust your baler. Because it's a dry product, it won't have the contact time to stick to the side of the baler. The way it works, we have an organic acid that first works to rapidly reduce the pH, prevent spoilage, stop any mold or yeast growth, and then the microbial catalyst and inoculant blend target the higher moisture areas within the bale to do a partial fermentation process, create more preserving acid, and prevent mold growth. So really target those mold pockets within the bale. And these two things together are going to help to save nutrition, so save nutrients in your bale. So we're going to have higher quality feed, and what that looks like in the field is bales that don't sag. So when you get some heating, you actually burn the structural carbohydrates and you're losing dry matter. It's being lost as CO2, and the visual effect of that is a bale that sags. So this gentleman in Texas is showing that his bale is as tall as it was when it came out of the baler. So we hear that a lot from producers, that I know this stuff works because my bales don't sag. So we wanted to look at quality as well. So we did a hay trial from July of 2015 through October of 2016 with hay that was baled at 18%. And at the end, we checked our goals to see if we could maintain relative feed value over time. So if you look at the control bale, that's the orange line, got up to over 140 degrees on average, with the hottest spot being 172. The control bales stayed below 100 degrees on average. This is over the first 30 days, and again, it was only 18% moisture, so big difference in heating even at that temperature. And then after, over a year later, this is in October of 2016, we cut the bales open, and you can see the treated on the left is a little bit greener. Overall, not a huge difference. But the thing that I noticed the most is that this bale opened up very easily. The control bale had white mold between the layers that kind of glued it together and made it really hard to open compared to this fresh hay that really flaked apart a lot easier. And then the next slide, you're going to see just a handful out of the middle, seeing that we had a lot greener hay coming out of the bale. And at the end, I mentioned the relative feed value goal. You can see that the treated bale maintained around 120, while the control dropped off steadily and ended at a relative feed value of around 89. Another thing I'll point out is this adjusted crude protein. A lot of labs won't give you this, so we request it. And what we test for is the acid detergent indigestible crude protein. This is going to be the heat-bound protein, or the protein that binds to the fiber. So it tests as being there, but the animal can't actually access it. There's a 1.5% standard there. So we didn't get docked for that 1.24%, while the control did. So you can see at the end there was a 6% difference in crude protein at the end. So that test was 18%. This was a customer at 28%. And it was a 3-month drought followed by rain. And when they got rain, they went and cut all 400 acres of hay. And then, 2 days later it was going to rain, so they went and started baling way wetter than they wanted to, but they wanted hay versus not. So the operator forgot to turn the applicator on for the first 2 bales. So we got 2 control bales, and 5 weeks after it was baled, they went and looked at these bales, and they saw a visual difference in the end. So we went out there and we actually cut the bales open, and you can see the control bale was really hot, really black, really caramelized, tobacco looking. Again, 5 weeks after it was baled. Another thing I noticed is that it was not cured down yet. So it was like a wet twig that roped and twisted, but you couldn't break it compared to the treated bale, which cut really clean. And the relative feed value at the end was 167 compared to 125 on the control. Another guy from South Dakota, this was baled in August. He opened it up in November, baled at 19%, and he was just amazed by how green it was. And you can see it's really flaking apart and really just kind of coming apart, nice fresh hay. He grinds a lot of his hay, so same guy. And And so he did a few control bales based on what he had previously seen. And you can see when it was sitting next to a pile, you can see the control bale is a lot browner. And a lot of people have the mentality that quality and grind hay doesn't matter because the cows are going to have to eat it. But when he blew that bale up in the pile, it didn't disappear. That's still going to be eaten, and it's still going to have an effect of being low quality to the animal. So sounds like a great product. How do I put it on? We recommend a Valmar box. Even though they're different colors, these are actually the same machine. We're just looking at two different mounting options. In 2018, Valmar switched to making everything in black. So everything that you'll get from here forward is going to be painted black. But I wanted to show the mounting options. So the picture on the left is mounted just in front of the transport mount. You can open up that door, and the top of this is around 6 feet off the ground. You can also mount it so it sits over that door. This gives you a little more room between the window if you go down a lot of ditches. And this is going to be just over 7 feet tall. So it's still accessible. It's just a little bit higher off the ground. The way this works is that air, this is a fan, blows air through this big tube into a manifold. The air goes in, product drops into 4 equal cups, and then the product and air gets blown back into the throat of the baler. The nice thing with this system, it can go in a round baler, but it also works great in a large square. So this is going to be your Massey or your Heston baler. This is a Challenger brand, but same design. It's going to work really well to put it right up front. And with that, there is a cab controller. So you can actually control the RPM setting from the cab. So it's the knob on the left. And because it's an RPM and it's a standard measure, we can actually make this calibration chart and provide that to you. And it's going to be the same in Minnesota or South Dakota or Costa Rica. Wherever we're applying product, it's going to be the same. So we aim for 2 pounds per ton between 16 and 25%. That's going to be for a round bale. A big square, you're going to want to limit to about 23. But if we look at a 1,500 pound round bale, we need 1.5 pounds in that bale. If it takes us 45 seconds to make, we need 1.5 pounds in 3/4 of a minute, which means we need 2 pounds per minute. So we would set it to 5.5 to be at that 2 pound rate. These are laminated cards that we do provide to producers so that they have it in the cab and they know how much they need to use. The pricing on the Valmars for 2019 is $4,236, and we do offer a $200 discount if they buy it with product. This is something we do with a lot of our partner dealers. Then this is our kind of pricing company-wide. Some dealers choose to do a little better deal than this, but this just helps us set up some sort of deal to the customer for buying product while still leaving a little bit of flexibility to the dealer. And we really do believe in our dealer network, so we want to work with them. We don't want to be going around them or discounting equipment to go direct to the producer. So this allows us to have some sort of a standard program. We do have a handout that does have the price on it. It does have some pictures that I talked through with the controller, the unit, the manifold, the product, as well as the calibration chart. And there is an install guide as well. So this is looking at everything from getting the box all the way through the mounting, including how to hook it up to the net wrap system on the John Deere 569 baler. And that allows it to automatically start and stop with the net wrap actuator. So the product itself, it's $71.50 per bag, which is a cost of $286 per ton. Each 50-pound bag treats 25 tons of hay. The cost to treat a 1,500 pound round bale is around $2.14. So it's a $2 investment in basically insurance to make sure that you're going to have quality hay and you're not going to have mold. There is an early order program with this. So I talked $71.50 per bag. If you do the early order system, you can get a $5 discount, which is a $200 per ton savings. And that gets it down to $266 per ton, or around $2 for a 1,500 pound round bale. The early order is put in the system with a future ship date. We choose May 20th unless you request a different date, and we do not bill product until it's shipped. Just want to touch on a competitive product here before we're done. I know sometimes there can be some question or some pushback in pricing. So looking at propionic acid, this is a very common preservative out in the marketplace. It's buffered now, so that makes it less corrosive, but it also makes it sticky, and it takes more product to get the pH to drop. So you're starting with a product that's a pH of 6 rather than a pH of 4, so it takes a lot more product. So if you look down here, the rate is very dependent on moisture because you have to make sure you're putting enough on to reduce the pH. So if you look at 20% hay, they recommend 10 pounds per ton, and at 80 cents a pound, it comes out to $8 per ton. And it is corrosive. So this is a customer's baler. I took this picture out in South Dakota, and you can see that even the stainless steel rod is pitted out. I took a lot of the paint off, and there was some on the tongue of the baler where the hay doesn't touch, where the acid had dripped down. There was also some paint missing. So comparing these products, we're looking at buying 1 ton of Anchor for Hay, which treats 1,000 tons of hay. So 2,000 pounds of Anchor is $2,860. If you buy the equipment at full price, the total for year 1 is going to be just over $7,000. If you buy propionic acid at $8 a ton to treat the same amount of hay, it's going to cost you $8,000. One thing I'll note is that each 250-gallon tote treats about 200 tons of hay. So I had a customer that was buying 3 250-gallon shuttles of propionic acid. He was able to treat the same amount of hay with 24 50-pound bags. So if you think about just the ease of handling of 24 bags, which you can put in the back of your SUV compared to needing a gooseneck trailer to haul 3 shuttles, it really is a big difference in just ease of handling. You also don't need a pump or a skid loader to load this product. You can pick a 50-pound bag up and bring it to the applicator without too much of an issue. So benefits to Anchor for Hay, and something that you can do to help your customers. You're going to help them put higher quality hay up. It's another touch point for your customers. So you might be selling them parts or net wrap. This is another way you can bring value to your customers. The nice thing with this product, and I say this with full confidence, I've traveled around the country and I've seen that it works all the time. So I had one customer tell me that this is the best innovation in haymaking that he's seen in the last 10 years. So he said, I can go out with the tedder and I can cut a day off. But if it gets too dry and I have to go rake it, I'm going to lose leaves. That's another pass. So I'm burning up more diesel. I'm driving over my field again. He said, with this product, I can avoid those disasters with baling high moisture hay or avoiding rain without having to change my practices. And another thing that you can offer your customers if they're already using a product is cost savings compared to what they're currently doing. Product's easy to use. We have a 2-pound rate from 18 to 25%, so we have a really wide window of application range. And I mentioned on the last slide that it's a 50-pound bag, so it's pretty easy to handle with a pickup or by hand. You don't need a pump, or you don't need to chase your baler around with a skid loader. So with that, are there any questions that came up?
Mike, I did get a question. Will it work on other baleage?
Yeah, great question. So if you have producers that are putting baleage up, this product will work well. I don't have a ton of research. I have more testimonial type situations. And what customers tell me is that if they use this product, they'll typically take the brown core out of the center of the bale, and they'll also reduce kind of that slime layer on the outside. So right underneath the plastic, there tends to be a lot of condensation that causes kind of a white slimy mold, and that is reduced with this product. So yeah, great question, Lori. It does work well there.
Mike, I have another question. This is actually a duplicate of one that was asked this morning, so it's a great question. What about other types of hay?
Yeah, another great question. So I talked a lot about alfalfa. That's where a lot of quality concerns are. But I'll use an example with corn stalks. There was a customer raising some natural pork that had mycotoxin issues in his swine herd. And he found out that the mycotoxin issues were caused by the mold pockets in those corn stalk bales that he was using for bedding. So he actually used this product on his corn stalks to help reduce those problems through his swine herd. But it works great if you're putting up rye hay or any sort of oatlage or oat hay. Any product that you're baling, it's going to work really well on. Was there any other questions?
Mike, I'm not sure if you can see this, but Kenny has suggested mentioning that the propionic acid, that the $8,000 cost does not include equipment cost.
Yeah, great point. So I assumed, go back to that. In my economic comparison, I assumed that the customer would already have the equipment. But the equipment to apply propionic acid is kind of $6,000 to $8,000, depending on automation. So $4,200 might seem like a lot when you're thinking about it, but compared to the alternative of propionic acid, the equipment is quite a bit more expensive, and it's also not included in this example. $8,000 would be the recurring cost each year. All right, any other questions?
I don't see any more questions here, Mike. So thank you everyone for your participation. Thank you for your presentation, Mike. Have a great day.
All right, thank you everyone.